by defining our density curves. So there are two things that fit into the definition of a density curve. First one is that your curve is always on or above the horizontal axis. And I will later, when I'm referring to the horizontal axis, I'll use HA, just so you know. The other part of a density curve definition is that the area under the curve is exactly 1. Density curves describe the overall pattern of a distribution. Area under the curve and above any interval of values on the horizontal axis is the proportion of all observations that are in that interval. Down here in this box, it says distinguishing the median and mean of a density curve. This box is in your book if you want to look it up. The blank of a density curve is the equal areas point, the point that divides the area under the curve in half. So do you think the mean or the median divides the curve in half? Median. The median's the middle. So the median will divide your density curve in half, which means the mean of a density curve is the balance point at which the curve would balance if it was actually made of solid material. The median and mean are the same for a symmetric density curve. So if we're looking at a symmetric distribution, your median and mean are the same. They would both lie at the center of the curve. The mean of a skewed curve is pulled away from the median in the direction of the long tail or the skewness. So you guys are going to have questions in your homework that look similar to this. They'll give you a density curve, and using that density curve, ask you to answer some questions. So first question says, explain why this is a legitimate density curve. So legitimate means we have to go back to our definition. Definition has two parts. The curve is on or above the horizontal axis, and the area under the curve is exactly 1. Here it tells us area under the curve is 1. So we got area equals 1. They don't do the best job making it like clear that it's on or above the horizontal axis, but since you don't have this line going through the middle of your density curve, you can assume that it's on or above the horizontal axis. And since those two things are met, it's an actual legitimate density curve. About what proportion of observations lie between 7 and 8. So here's 7 and 8. The proportion, remember, is the area under the curve that is above any interval of values on your horizontal axis. So this whole little section here, which they tell us has an area of 0.12. So 0.12 of the observations lie between 7 and 8. Part C says mark the approximate. So we're going to do our best. Doesn't have to be perfect. Location of the median. Median does what to a density curve? Cuts it in half, right? So the median divides the area in half. So we're going to approximate where half of the area of the curve is on one side and on the other, which there is skewness to the left, so it's going to be, I think, around here. Again, we're approximating, but that looks about half and half, right? Do you guys agree with me? Thanks, Aiden. I think it looks pretty good too. So that's the median. And then now we're going to mark the approximate location of the mean. And then we're going to answer the question about why do the mean and median have the relationship they do in this density curve. So first of all, is our mean going to be in the same place as the median? So the mean and the median would be at the same place if the density curve is symmetric. This is not symmetric. We have skewness to the left. And remember, it says the mean of a skewed curve is pulled away from the median in the direction of the long tail. So since we have the tail on the left-hand side, our mean is going to be pulled to the left. So we'll approximate about there. Again, it's approximate. And why do they have this relationship? So we know the mean is less than the median because of the skewness to the left. And that all boils down to the fact that the mean is non-resistant to outliers and skewness. Are there any questions so far? All right, now we're gonna, did you say wait? Sorry. We're gonna talk about normal curves next. Are we good? All right, so normal distribution in the normal curve. So there are 4 characteristics of a normal curve. Normal curves are just a special class of density curves. Normal curves describe normal distributions. And yes, you will start to notice that normal will be capitalized in the middle of a sentence. That's because they're so special. Normal curves, normal distributions, they're special, so we capitalize the word normal. This one's my favorite. They're not normal at all. They're actually quite special. It's my favorite thing to describe normal curves. And they still have an area under the curve that is equal to 1. All normal curves will have the same overall shape. They are symmetric, unimodal, and bell-shaped. So if they're symmetric, what does that tell you about the mean and the median? They're the same, and they're going to be at the center of your normal curve. Normal curves are completely described by the mean and standard deviation. And in fact, all your sketches will have to be labeled with the mean and standard deviation. And of course, it wouldn't be math if we didn't decide to change notation on you. So mean, you may also see it with this notation now. That's the Greek letter mu. It's kind of a mu shape-ish. If you type it in the computer, it kind of looks more like that. I put a little angle on mine. It's mu. Mu. It's a Greek letter. So mean, you can see that notation or the X bar. And standard deviation, we used S sub X before. Now they may use sigma. That's a lowercase sigma right there. That is also a Greek letter. And sketches, like I said, must be labeled. And we'll look at sketches in a little bit. But you'll put a capital N, which means that it's normal. And then you will put the mean and the standard deviation in parentheses with a comma in between. Sigma is the standard deviation. Like we talked about earlier, because it's symmetric, the mean and median will be at the center of the distribution. Standard deviation controls the spread. So the larger your standard deviation, the more spread out your distribution is. Can I move it up? Oh, wait a minute, I see some used already. So all normal curves and normal distributions will obey the following rule. So if we have a normal distribution with mean mu and standard deviation sigma, approximately 68% of the data or observations fall within plus or minus 1 standard deviation of the mean. Approximately 95% of the data fall within plus or minus 2 standard deviations of the mean. And then approximately 99.7% of the data fall within plus or minus 3 standard deviations of the mean.